Today, for a change, we have a Hackerrank problem. Uh, the question's name is count triplets. So, what the problem states, we are given an array that we need to find number of triplets of indices I, j, k such that the element at those indices are in geometric progression. And here is an important thing given for a given common ratio r. So we'll be given an array plus the common ratio r, and here is this condition that the three indices that we'll check uh, should follow this such that I must be less than j must be less than k. So let us see an example. The given example, this is the array 1 4 16 64. So and here the common ratio r is 4. So if you look at this array, then 1 4 16 are in GP with common ratio 4. Similarly 4 16 and 64 are in GP. So there are two geometric progressions in this array with the given common ratio r equals 4, and these are their indexes. So we need to print 2. Okay, so that is it. Function description, we have to complete the function. Okay, this is the input format. The first line contains two separated integers n and r, and the size of ARR and the common ratio, this all constraints. Okay, so look at the sample input. Though we have looked at one of the sample inputs above also, but let us see here. Okay, 4 is the size of array, 2 is the common ratio. If you look at the array, 1 2 and 4 are in GP, and 1 2 and 4 are in GP, so there are also 2 GPs, so the sample output is 2. Similarly, if you look at this example, so in this 1 3 and 9 are in GP. Similarly 1 3 and this 9 is in GP, so 2 1 2 3 3 and 1 2 3 4, and you can simply look here, these indexes are given. So just observe that in every case it is following the rule that we were given above, such that I is less than j is less than k. So basically we need to just find the number of GPs in the given array with this rule following: I must be less than j must be less than k. So how are we going to approach this problem? Let us see. So suppose we are given this, the size of array is 5. These are the 5 elements. These are the 5 elements: 1 2 5 25 and 125, and the common ratio given is also 5. Okay, so r is 5 and size of array is also 5, so we need to find the number of GPs for this array. So the approach is simple. First of all, let us see. You might remember the questions that we were given in class 12th also in mathematics. If we were given that 3 terms are in GP, okay, so what we used to consider, like, if I say, so similar case will be followed here also. What we'll do, we'll simply search for an A in this array. If we get an element A, then we will check whether A by R is present in that array or not, and if A by R is also present, then we look for AR, and if we find all of these, so that means there is one pair. Okay, so that is how we'll approach the problem. But one way can be, I search for every element. I take it as A, then I search whether A by R is in array or not. Then I'll search whether AR is in the array or not. So in this way I have to take each element, consider it as A, and then search for A by R and then AR. So if I'll go by this approach, that is super inefficient. So how to do it in a more efficient way is by using hash maps. So we'll do it by hash maps only. So I have written here two hash maps. We have to take two hash maps. One is the previous and one is the next. I'll tell you what are these. So there will be two hash maps. Okay, so first of all, as we'll first go iterate through the array. Okay, and we'll take each current element. Uh, okay, let us start here. First of all, what I'll do, I'll put each and every element of the array in the next hash map. Next hash map basically represents the elements which we haven't visited yet. Okay, so first of all, what I'll do, I'll transfer all the elements of this array in the next hash map. So next hash map, what it contains a key and value. Key will be the element stored in the array and value will be their frequency. So what will be stored in the next hash map, there is one element. Okay, and one is one times only, so like this. 5 has a frequency of 2 in the array that we are given here, and similarly 25, it has a frequency of 1, and 125 and frequency of 1. Okay, so this is what in next hash map. So when we start from 0, our previous hash map will be null, and here we'll have the current element. Okay, so we'll start iterating from array from the 0th location. Okay, so first of all we'll come across 1, and as soon as we come across 1, so from the next hash map its frequency will be 0, as we are looking at a 1. Okay, so current element is 1. So we'll look whether 1 by R, here R is 5, if 1 by 5, and since the data type was long, so it's 0. So we will check whether 0 is in previous hash map or not. So as since it is empty, and also 1 by 5 it doesn't mean anything, so we simply know that there is no A by R for this element, so there can't be any GP for the current element 1. So we'll simply go to location 5, location 1, first element of the array, and the current element is shifted, so we'll transfer it here 1. So now the previous hash map has a 1 and its frequency is also 1. Okay, and now the current element is 5, so I'll transfer 5 here. We look at 5, and now the frequency is also 1 less, since we are looking at 5 now. So we'll look at 5. So 5, suppose now A here is 5, so if A by R is present in previous hash map, yes, 5 by 5 is 1 and it is present. And what is its frequency? Its frequency is 1. Okay, so and now if A by R is present, so we now look for AR. So A is 5 and R is also 5, so whether 25 is present in hash map or not, yes, 25 is present and its frequency is also 1. So okay, so we know that there is one pair. Now here comes the concept of frequency. You must be wondering why I am including frequency in here. This is because suppose I'll return sum is our output. Okay, so there is only one 1. Okay, so what we'll do, we'll simply multiply the number of 1s and number of 25, that is also 1. You think of some case, if suppose we were having two 1s. Okay, so what would be the output? Suppose if there would have been another one, so one pair would have been 1 5 and this 25, the other one would have been 1 5 and 25. So there would have been two pairs. So that is why I'm considering frequency, because I'm just simply multiplying the number of fives. Okay, so that is the concept of frequency. So now since we have considered 5 also, so I'll cut it from here and I'll place it in here, previous hash map, and now the next 5 comes in and its frequency is 0 now. So for this 5 I look whether a by r is present or not and its frequency. So yes, there is 1 and also there is a 25 also. So and their frequencies are 1 and 1. So I'll simply now add. Okay, now we have looked at this 5 also, so I'll simply cut it from here and its frequency will be included, will be added, because it is added in the previous hash map. Okay, and okay, 5 is done. Now we'll consider 25 as our current element. 25 frequency is 0 here. Okay, so if a by r is present or not, yes, a by r 5, its frequency is 2. So, and AR, yes, 25, there is its frequency is 1. So the sum will be twice 2 into 1, it is 2. Okay, so now 25 will be shifted here. 25 frequency is 1. And now the last element that is left, 125, we'll consider 125. If a by r of 125 is present in the previous hash map or not, yes, 25 is there. So we'll look for AR. There is no AR, so nothing. So the output will be simply 4. So that is how we are gonna approach this problem. And now let's jump on to the coding part. Let's now code. So this was our sample case that we did just moments ago. So now we'll jump onto the coding part. Here we have to write, okay, the function. So what we have to do, we'll first have to take two hash maps of long, since we are given the common ratio in long, so their type will also be long only. So one is previous one. So there will be two hash maps. I'm just gonna copy it. Where was this? Next. Okay, so after that what we did, we just simply transferred all the elements of array in the next hash map. So I'm just gonna do that only for long a. Here nothing, we have done that only. We have just simply transferred the elements of elements of array in hash map along with their frequencies. Okay, nothing new here. Now we'll iterate through the array. Okay, so far so good. Now we'll take a long current. Okay, and the right count and left count are two variables that denotes the frequencies. Here we multiply 1 and 1. So what right and left count are doing, left count and right count are the frequencies of the found elements. The frequency of a by r and frequencies of elements of ars. So what we'll multiply and add it in sum to return the value. Those are right and left count. Okay, so after that what we did we simply pass the current element. We just subtracted the frequency of the current element from the next hash map. So here it is. Now after that we'll search whether the current element, if the current element suppose is a, so whether a by r exists in the previous hash map or not. So if previous that contains key, what is the key? Current divided by r and so why we have written current modulus r equals to 0, because this will not ensure whether r is perfectly dividing current or not. So this modulus here will ensure that. Okay, so if the a by r is present in the previous hash map, so we'll just what we'll do, we'll simply in left pointer, we'll simply add left pointer. So left count just dot so what we have done here, we have simply initialized the left count and if we found the element in left or the previous hash map, what we'll search for it in the next hash map. Next dot contains key current into r right count. So after this, suppose we got our matches in the left or right, you can say, hash map or the previous or the next hash map. So we'll simply just pass it on to the sum. So what is sum? Sum is basically the multiplication of right count and left count. That's what we'll do here. Okay, so after that we will simply add the current element to the previous hash map. Dot put current element to the we have simply added the current element to the previous hash map, and close the loop here and just return the sum. Okay, so this is the function overall. Starting from two hash maps, so we simply just added all the values of the array in the hash map in the next hash map. Now we'll take one by one the values from right or the next hash map, and we'll check whether if we take a as the current element, then whether we have a by r in the previous hash map or not. If we found a by r, then we'll search for ar and we'll simply multiply their frequencies and we'll add it in sum and we'll return sum. So this is all. Now let's run code. What is the error? Long cannot be converted. We have taken somewhere, and yes, must be long since all the data type is long here. That's why it's showing some error. Check for it. Oh, again. Sum. What is wrong with sum? Okay, sum is not initialized. Many of errors. No, you have to initialize long. Hope it runs now. Oh, finally. Now just submit it. Oh, so finally all the green ticks. So that was it, and it's a very famous problem of hash maps. So see you in the next.